This is Algebra 2, Lesson 10-10, Multiply and Divide Rational Expressions, the medium difficulty. Today's date is Tuesday, April 28th, 2020. Our objective today is to multiply and divide rational expressions, again, just like 10-9, but now they're going to require some factoring. And all I'm going up to today is GCF and Ninja Star, no advanced Ninja Star today. So example 1, we have to multiply these things, and then we have to find the values of the resulting expression. So I'll kind of underline that, that's the important word. That make that resulting expression undefined. So obviously if we factor this thing right now, there's going to be a lot of different values of x that will make it undefined. Like, for example, if I plug in 0 here and here, then it's going to make this entire denominator undefined, but it only wants what happens at the very end. So the first step here is to factor. The second step, cross out anything that looks the same, and then just kind of multiply straight through. So let's go ahead and set this up. I'm going to do factoring for the top. Okay, there's only two terms here. I'm going to always start with the greatest common factor. What's the greatest common factor between 3 and 12? So that's going to be 3. So I'm going to write this down here. This is going to turn into, I think, to the left here. So 3. And then what's the greatest common factor between x squared and x? That's going to be x. So 3x is the greatest common factor for those two terms. When I factor out that 3x, what's left over is x. And then this negative 12x divided by 3x is just negative 4. So I'll say x minus 4. All right, so I just rewrote that numerator. I'm now going to factor the denominator. Again, it's just always start with GCF. There's nothing more that I can do to factor this thing. There's no extra x squareds. So that's why I'm done. Okay, the denominator. Greatest common factor, clearly 6 is going to be factored out. And what's the smaller power between these two? It looks like x squared. So I'm going to factor out a 6x squared. So 6x squared. And what's left over? I'm left over with just an x and nothing, right? So 6x squared divided by 6x squared is 1. So I say it's a positive 1. I'm kind of copying down the sign here. So it's going to be x plus 1 for that denominator. Okay, so I've rewritten this fraction, but I factored it. The right-hand expression is going to require some ninja stars, though. So I'm going to do those ninja stars out here to the left where I have some spare room. So the first step, though, before I do ninja star, always your first step is greatest common factor. So what is that greatest common factor? Maybe I can write it up here. It looks like it's just 4. Again, this 12 doesn't have any x in it for that term, so I can't factor out an x. I can only factor out 4. When I'm factoring out that 4, what's left over? I have x squared plus 4x plus 3. Okay, so I'm going to advance not advanced ninja star. I guess that would work, but I'm going to just do a normal ninja star on that one right here. So that's going to be a ninja star. And I'll do that out here to the left-hand side. So the question is, what two numbers add to 4 and multiply to 3? Well, there's only two things that multiply to 3, and that's 1 and 3. If I leave them both positive, they add to 4, so done. Okay, so I'm going to go ahead and write that whole thing right here. So it's going to be times. I still have to rewrite that 4 that didn't go anywhere, so 4. And then these two terms, 1 and 3, so it's going to be x plus 1, x plus 3. X plus 1 and x plus 3. All right. What about the denominator? Again, I'm looking here and I'm seeing there is no greatest common factor in this case. There's no x that I can factor out. There's no numbers in front of x, no coefficient. So I'm just going to have to go ahead and ninja star that again. So let's ninja star this one. What two numbers add to negative 1 and multiply to negative 12? That is a negative there. Let's go through the factors of 12. 1 and 12, no. 2 and 6, no. 3 and 4, oh yeah, 3 and 4 will somehow get a 1. Since it's a negative 1, it needs to be a negative 4. The bigger number needs to be negative. And let's check everything. 3 times negative 4, negative 12. Okay, it works out. So that denominator factors to x plus 3 times the quantity of x minus 4. So we have rewritten this multiplication of rational expressions, but now factored everything. And I think that's about the hardest level of factoring you'll ever get. Like, you'll have a GCF, maybe there'll be an x in it, maybe there'll be a coefficient, but nothing above ninja star for at least today's lesson. Next lesson we'll have harder things. Okay, so that's the first step. The next step is to start crossing things out. Again, when I'm multiplying fractions, it's another way of saying I'm kind of just extending this line. It's now just one giant fraction. So what do you see on the top and the bottom that you can start crossing off? Well, I see an x plus 1 and an x plus 1. I see an x minus 4 and an x minus 4. Ooh, an x plus 3 and x plus 3. Ooh, okay, so this one is a little bit more tricky. An x and an x squared. There's one x on the top, there's 2 on the bottom. So I'm really crossing off 1 on the top and 1 on the bottom, so there's only 1 left over on the bottom. Also, I guess I can simplify and cross cancel here. 3 and 6, I know I'm crossing out tons of stuff, but the 3 and 6, 3 divided by 6 leaves 1 up here and 2 in the denominator because 3 6 reduces to 1/2. And then that 2 that I just wrote can be cross canceled with this 4. 4 divided by 2, that 4 turns into a 2, that 2 turns into a 1. And wow, I have crossed out almost everything. So in the numerator, what's left? 1 times nothing times 2 times nothing. So the numerator is literally just 2. What's the denominator? The only thing that's left over is x. It's x times 1 times 1 times 1, and the answer is just 2 over x. So it's crazy that all of this math can boil down to something so simple. So that's the first part of this problem, but it also tells us then find values of x that make the resulting expression undefined. And again, undefined just means, this word here just means that I have set the denominator equal to 0, set the bottom equal to 0. And this one is pretty straightforward. If I set x equal to 0, the answer is x equals 0. So I'll write down here, x equals 0 makes 2 over x undefined. So maybe I'll box this as well. Cool, so that's an entire problem. And let's move on to another one, slightly harder. I guess I should have moved it up. There's a bunch of voices space up there, but example number 2. Now instead of multiplying, we're going to divide. So this is where I'm going to keep it, change it, flip it. I'm going to keep this entire fraction the same. I'm going to change this multiplication to, change that division to multiplication, and then I'm going to take the reciprocal of this side and flip the top and the bottom. So there's going to be a few steps here. I think the first step is always just factor, right? So factor, numerator up here, y squared, there's nothing I can do, it's just y squared. What about that denominator though? So again, always start with GCF, greatest common factor. 6 and 7 are co-prime, there's nothing I can factor out of anything, so I'm gonna, greatest common factor is 1, I guess, and then I'm gonna go ahead and ninja star this thing. So let's do that off to the side. Ninja star, what two numbers add to -6 and multiply to -7? All the factors of 7 are 1 and 7, so somehow I have to make these multiply to -7. One of them needs to be negative. There, okay, that works. So 1 plus -7 is -6, and they multiply to -7. I'm good. Let's go ahead and write that down. So in the denominator, I have y plus 1, and I have y minus 7. Okay, so I'm going to go ahead and do a few steps at the same time. I'm now going to change this to a multiplication symbol, and I'm going to flip this while I factor it. Hopefully everyone can follow that. So I'm going to factor this y squared plus 6y, and I'm going to put it in the denominator. Maybe I should put the denominator first. So what is the greatest common factor? Well, these terms both have a y. There's no number I can factor out because that's a 1 in front of the y squared. So y is the greatest common factor. When I factor out y, what's left over? I just y and then plus 6. Okay, in the numerator, that's going to be really the denominator down here, factored right here, because I'm flipping, I'm taking the reciprocal. Again, always the first step, take the greatest common factor. And in this case, it looks like 3. I think I can factor out a 3. So if I do that, I'm kind of running out of room. I think I can write it off to the side here if I write small. So if I factor out 3, I can't factor to y because 18 doesn't have any y in it. So if I factor to 3, what's left over? I have y squared. I'm just dividing each of these coefficients or terms by 3. So 21 divided by 3 is 7, so it's going to be plus 7y. And 18 divided by 3 is 6, so plus 6. Okay, well this quadratic expression here needs a ninja star. I cannot spell ninja. I always want to put a G there for some reason. Ninja star. So how do I ninja star that thing? I'm gonna come out here and say what two numbers add to that middle term 7 and multiply to 6. So list all the factors of 6. 1 and 6, no. 2 and 3, oh wait, 1 and 6 is a yes. 1 and 6 make 7. So that first one works. Cool, so I'm gonna go ahead and rewrite that 3. That doesn't go anywhere, it's still factored out. And then I'm going to write these two factors. It's going to be y plus 1, y plus 6. So writing those down, y plus 1 and y plus 6. All right, and again, now that I've turned it into a multiplication problem instead of a division problem, I can basically just extend this fraction line and say this is one giant fraction. Now cross off whatever you see that's the same on the top and the bottom. Okay, not as many things cancel out, but still some things. So the y plus 1, y plus 1, a y plus 6 and a y plus 6. And that's about it. Okay, so I have a y squared and a y. So this is y squared is essentially saying y times y, right? So I'm going to cross off one of those y's and one of those y's. And a more sophisticated way of saying that is, keep that canceled out. A more sophisticated way of saying that is cross off one of those y's, so one of them is left over, and cross off one of those y's. All right, and I think that's all the crossing out that we can do. So the resulting expression is I have a y up there and a 3, that's it. So 3y for the numerator. What about the denominator? The only thing that's left over is this y minus 7. Okay, so here's something that a lot of people make a mistake. They think, oh, well now I can reduce some more. There's a y in the top, y in the bottom. This is incorrect. This is incorrect because they can only be crossed off if they're being multiplied. These two terms, y and 7, are being subtracted. They're not being multiplied. So I'm done. That's as far as I can go. That is my final answer. It's just 3y divided by the quantity of y minus 7. Okay, well that's the first part, right? It's asking, go ahead and simplify the result. We did, and there it is. And the second part of the question is saying, find the values of y that make the expression undefined. So I'm going to set that denominator equal to 0. And sometimes you'll have more than one term. So you might have to use the zero product property and say each of these is a value that makes it undefined. But this is only one that I have to do. So I just say, okay, right now I guess I'll notate my work. This is the undefined part, undefined. And that's where I just set that entire denominator equal to 0. So y minus 7, set that thing equal to 0. And I guess I didn't really need parentheses there. Let me erase those. Y minus 7 is equal to 0, and therefore add 7 on both sides. Y is equal to 7 will make this expression undefined. And I guess I really, for next year, I need to make this so that there's multiple numbers on the bottom, because sometimes you'll have something like, I'm just totally making up numbers right now. What if I had something like 3y over y minus 7 like I had before, but also I just had a random x plus or y plus 1? That would mean that there are two values that make it undefined. 7 makes it undefined for this factor, and -1 would make it undefined for this one. So you'd have to use the zero product property and say each of these things could possibly be 0. But we didn't have that case, so I'll go ahead and leave that. That's all I have for you guys. That's about a 13-minute video. I will see you guys tomorrow.